Sandrilla, ¿qué dijiste?
30 segundos para iniciar, profe, porfa.
Para iniciar. Ah, ya.
Ya pueden iniciar.
Gracias. Muy buenas tardes a todos. Gracias por atender a esta invitación. En el marco de las actividades de cooperación e interacción entre la empresa BGP, Nueva Granada, y la Universidad Nacional de Colombia, se ha organizado este workshop con el gentil apoyo de la empresa BGP y para llevar a cabo la presentación a cargo del señor Hao Yang, quien intervendrá a continuación con la presentación de Application of Distributed Optical Sensing in Oil and Gas. Unas pequeñas palabras acerca de la charla y del expositor. BGP applies distributed monitoring technologies such as ESP, microseismic and fiber optics to enhance reservoir characterization, hydraulic fracturing evaluation, and production monitoring. These solutions provide high-resolution imaging and real-time analysis, with successful application in various reservoirs and CCUS monitoring. Key development will be featured at the application of distributed optical sensing in oil and gas events. So, Mr. Yang, thank you very much for attending this invitation. We are very excited to have your participation here, and hope that sharing your knowledge and expertise will increase our knowledge and possibilities in our activities related to this field. Please, so thank you again, and please.
Thank you. So, good afternoon, everyone. So, today I'm going to talking about the new technology for the DAS, distributed output speed sintering technology in oil and gas production as slow operation. So, first of all, I just introduce myself. So, my name is Hao Zhang. So, I'm from the BBP, so another division, both seismic division. So, normally I'm the VSPs. Is that work? It's working. Okay, so I'm working on the two kind of work. The first one is about the DAS VSP. We apply the fibers in the borehole and we record the VSP data. And another things I just working on the monitoring, like the microseismic monitoring and the optical fibers monitoring. It's also very huge application around the oil and the gas fields. So let's first we just start with a small video. So this is that way doing the work. So let's get started.
Delivered a wide range of borehole geophysics services to energy industry. Waterline with 3-line cables. And have deployed 100 optical cables outside the casing for tubing with series DAS interrogator. Since a number of fiber optic sensing technique has been broken through, such as enhanced receiving ability to readily backscattering, we have innovatively launched a series of new DAS interrogators with a minimum detachable signal up to 8 strain. Meanwhile, in order to acquire higher quality data, we realized that the deployment of cables connected outside the casing and strapped along with the tubing. Also, we have developed AI dust. Two is DSP. Two is DSP. Two is DSP. Two is OPM. Two is the control software systems. We have a strong scientific and technological innovation team, reservoir geophysics and instrument R&D teams led by several national experts in the industry who have worked in field over 30 years, formed a multidisciplinary and all factors innovation power. Also conduct in-depth research on cable placement processes and cable structures. The problem of downhole coupling was overcome. Developed a series of supporting downhole tools, accumulated a lot of construction experience. Currently, the UGP borehole department owns and operates a fleet of 8 VSP crews, as well as 30 seismic data processing and interpretation centers distributed in China and overseas. UGP has completed nearly 7,000 well borehole geophysics operations. Focus on zero offset VSP, offset VSP, walk away VSP, look around VSP, cross well seismic, 3D VSP, borehole surface, borehole offshore synchronous acquisition, pressure microseismic and stream detection, intercluster competition fracture evaluation, injection and production logging, well integrity logging, underground gas storage maintenance monitor, and pipeline safety monitoring. As the most efficient tool connecting the geology and oil extraction, especially fiber optical sensing technique with high density, full well bore coverage, high temperature, high pressure endurance, and easy deployment boosted recently, help engineers recognize and monitor reservoirs' dynamic changes explicitly. Another huge challenge that came through was how the fiber survived under perforating conditions. Then we gradually used the sliding sleeves for low-risk fiber downhole, and later realized that the application of APS to self-oriented the cable and directional perforation to assure the fiber safe. Furthermore, the successful realization of high-quality 3D VSP imaging offshore has greatly enhanced the effectiveness of joint borehole surveys offshore seismic survey. This achievement is attributed to the compilation of certain migration imaging algorithms in the borehole observation system. The utilization of these algorithms maximizes the potential and efficiency of these borehole surveys offshore joint survey approach. Here we can monitor and diagnose each process of fracturing, as well as monitor liquid and sand impacts targeting a single cluster. And production of oil and gas wells varies with different manufacturing control. The time-lapse vibration, strain, and temperature point information in the spatial domain provided by optical fiber sensing drives the changes in the fracture network and fluid network at the oil plant level in the temporal dimension. Through the integration of microseismic and optical fiber sensing, it is possible to achieve a more scientific evaluation of the fracturing effect of the wellbore to formation. BGP has an unparalleled seismic geological big data foundation in oil and gas development, and borehole geophysics can produce a composite, time-long, and more appreciate reservoir modeling renovation of such fertile soil.
So let's back to this workshop. So let me start my presentation. So today I'm going to present on the topic of the application of the distributed optical sensing, the oil and gas exploration and production. So today I'm just focused on the technique of the distributed optical sensing. So normally we have the three kind of the distributed optical sensing principle. So the first one I just introduced very briefly here. So it's DAS, what we just widely use and applied in the oil field. And another is the DTS, so distributed temperature sensing. And another one is DSS, so it's about the stream change. It's kind of the very small stream change can be just detected by the DTS system. So let me just start. First of all, so I just introduced my division. So I come from the borehole seismic division. So we focus on the fibers optical solution on the reservoir geophysics. Why we call the reservoir geophysics? Because we just extending the exploration method to the production wave. So in our division, we focus on the three kind of the main jobs. The first one is about the reservoir characterization. It's about we using the borehole seismic to introduce and to do some of the immigration, main imaging, and another work we doing the long-term dynamic monitoring of the reservoir. So it's also kind of the monitoring the way to monitor the reservoir change, the fluid change, and the pressure change. We can monitor the precise of the fractures, hydraulic fractures going well. And this is only the research components of the division. We also have another department of the fibers, structure, and the integrator development, research and development. So basically, we just research a very good technique. We develop a series of the DAS UDAS system. And we also just develop the fibers cables deployment inside the borehole and around the surface. We're using the HWC, the horizontal bonded fibers, to acquire the seismic, surface seismic data. So later I will give.
Este perro se murió, mire. Esta mierda no carga, amor, ¿no?
So this is just what we introduced before. So we have some four main works. The first one is VSP.
¿Y es humillante, son humillantes los idiotas esos? Sí. ¿O son buena gente? ¿Una mierda? ¿Sí? O sea, los ven como mierda a ustedes. ¿Sí? Qué pena.
We focus on the zero
son
Levantados.
sí, se levantan de mucho los huevos.
and normally today
Yo conmigo, no, yo conmigo, les doy duros.
So this is the way
No soy servil ni con latino, no voy a servir con desgraciados. No soy servil ni con un gringo, que los gringos le dan a uno todo. Un gringo lo pone a uno a comer bien, a dormir bien, lo manda en primera clase.
Luis León, por favor, ¿puedes mutear? Luis León.
And the second work, we focus on the dynamic monitoring. And we can use in the develop a fiber in the borehole to monitor the fracture precise of the operation, like the ball setting and the preparation, and then going through the fluid inside the reservoir to form the network of the fractures. And another thing, we can use the fiber to do the microseismic monitoring. We just using the passive way to monitor the microseismic event developments. Then we can just evaluate the fractures, the network, the preparation, and the developments. And then another very good application we use in the fiber in the production logging. So that means if you just deploy one fiber in your borehole, you can do a lot of things together. From the very beginning, using the fiber before the perforation to the VSP and the exploration, and then you can using the fiber to monitor the fracture and then the production rate. So this is what we call the industry choice of the work. So, and then we using the fiber in another field outside the oil and gas field. We using to find out some leakage and the cement quality and pipeline security as well. So we deploy the fiber inside the underground gas storage project and CCS and CCUS project as well. So all of this we just form the giant seismic, geologic, and engineering solution together. So this is what we call the BGP's fiber solution. And this is our integrator. So UDAS system is in the principle of DAS. So here I will just introduce briefly the principle of DAS. So this integrator will just release the light pulse constantly at the very small times, like 10 milliseconds or the 20 milliseconds light. And the light will go through the fibers cables from the very beginning of the pathway. And there are some this point, they can just this is the forward light, and at this point will the back scale the light on the backway. So the indicator will measure this small change by the fiber. If you just exerting the small force or the vibration on the fiber, the light speed will change. Then using the indicator, you can just emote the small change to the string or string rate. So this is the principle of DAS. So we just develop a very sensitive DAS system we call the UDAS. And as you can see here, the string sensitivity is less than the 1.5 pico string rate at the 20 Hz. So this is very small change. Pico is like the magnitude of -9. So it's very small. I think it's only the like very tiny the higher you can have small vibration on the higher it can be detected by the interrogator. And we can using this have very small sampling rate, only 0.1 meter. So that means you just using this system to require the certain data you have obtained very high density data in a very small, I think, not small, very long distance up to the 100 kilometers. So only using one interrogator. So this is what we done several years ago. So we just joined the invitation from the American Sodium. So they just prefer the DAS VSP field test. This is the standard test. We just perforation or just one wheel. We just do this acquisition with other 5 companies. So this also the very famous company around the world, like the Halliburton, so Halliburton, Silixa, and Luna. So there's optical fiber solution company, and the OptiSense as well. So all this is from the American and the British. BGP only went from the China, so we are invited to do this field test. And this is the comments from the American. So both of our interrogators have a very exceeded expectation. So up there is the expectation. And the quality of the DAS data is also impressive. So the quality of data is very good compared with other companies. And the total acquisitions length is over to the 45. This is the oldest version indicator. Now we can use the indicator to acquire the 100 kilo. So this others interrogator with what we call BTS and low frequency dust. This was we using in the fracture monitoring because of you when you just have the perforation and you just pop the fracture fluid inside the reservoir. The change rate is very small change, and the frequency is less than 1 Hz. So we're using the low frequency dust to monitor the small change of the perforation rate. And this indicator is very sensitive as well. And another thing we just developed the borehole seismic pentameter. It's the pressure and temperature gauge. You can use in the fiber connected with the small things to measure the downhole pressure and temperature in the same time. Because you know, if you're using the electronic gauge in the borehole, the lifespan of the electronic gauge is very short, maybe just few days. But if you're using the fiber optical pentameter, it can be using for the life more than 10 years once you connect it well. And we also just do some work in the optimization of the fiber cable structure. This is not a small thing. I think this makes sense. You know, in the borehole, they are a very hard environment. The hand temperature and they have some fluid to just bridge the fractures of the fiber cable. So we just developing several types of the fiber cables, and we just put the fiber cable outside the various deep, and this can be developed in a very deep well with a very high temperature and pressure. So normally we just have 3 deployment methods for the fiber cable. We can deploy the fiber inside the casing. So this is using like some gravity or using some magnitude to attach the fiber cable to the borehole wall. Another, you can just, new well, you can put the fiber cable outside the casing. And then you can just put the fiber outside the tubing. So this is in the production well. So among these 3 methods of the deployment, they have some disadvantage and disadvantage between those. The first one is use the deployment outside the tubing. So this is in the production well. So you don't need to take out the tubing. So you just to pull the tube, you pull off the tube and you bunch the fiber outside the tubing, and then you just deploy the tube with the fiber together in the same time. And in this way, if you just using the outside tubing fiber to record the VSP data, because they have the fluid in the borehole, they will have some stream on the background noise. This is cannot be avoidable. And another, if you just put the fiber inside the casing, because this is a well without any production tubing. And in this way, we can just deploy the fiber part to the wall of the borehole for the coupling. If the fiber is just in the center of the well, it can be just like vibration, and then it's not solid way. In this inside reading, we need to do some like mechanical attachment or the using some the arm to attach the wall of the borehole to just avoid the coupling issue. The third way is we just new well, we deploy the fiber cable outside the QC. This is in the drilling processing. You put the fiber to outside the tubing, and then you cement the fiber inside the reservoir. This is very good way, because in this one you can have very good coupling, and there's no like the